was just tired of doing yesterday, and I made it through the day and practice.
And you've got.
Hey, could you tear my piece of paper and use
Just cut up a piece of your job, and then go by the time home before.
Alright.
Top of my shop.
I watched the videos where it's
It's typically a month.
Okay. Alright. Okay, today, I want to go through this pretty quick where we actually simplify radicals down to the simplest radical form. We're going to do that. The shortcut today, we're going to practice more on the exponent rule, like where you have the fraction for the exponent. I hinted at that yesterday. I think it was like the one of the last few problems we did yesterday. It was maybe second to last or something. We're going to do a lot of quotient rule today to practice because I think I only did one or two of those yesterday for you. I want to make sure you guys get to see that for like a cube root and other things with variables in it. And then the last thing we're going to finish with is a new problem. So in theory, I want to do basically 3 or 4 problems. I want to do an exponent problem with a fraction, quotient rule with some actual variables in it, and then a sum and difference problem. So like 3, 4 problems, something like that. Okay, I'm going to go through this pretty quick. We are getting homework today. Homework today that we'll get, I haven't put it up there yet, it'll be due on Monday. So you'll have a ton of time to work today. Tomorrow we're just taking a few notes anyway, so you get some time at the end of class tomorrow, because it'll just be kind of a lightning true today. And then Monday it'll be due. Got it? Perfect. So let's talk about the actual quotient rule. So this is where you have a fraction up in the power, like such. So let's go through and let's do a problem like 16x squared y to the 7th z to the, let's go with, I don't know, 12. Those are different numbers. Doesn't matter if it's positive or negative. That's what we're going to do. Goal is to simplify. So what does the 1/3 actually mean? What type of radical? Cube root, right? Got a power of 3, got a cube root. The reason why we know that, it's got a 3 on the bottom, that's the root. Now you don't need to write the actual radical sign. I want to show you how we can do this without the radical. So you can learn how to simplify. All right, so we're looking for triples, basically. The 1 on the top means the power that's on it. You could actually, there's one way to do this is you could, if there's like a 2 or a 4 on the top, you could distribute the top number first, and then take the third of it, the actual like cube root of it last. Like you can like interchange if there's 2 different numbers here. Like you can go different order. You can distribute the top number, then take the third. Or take the third, then distribute the top. There's 2 different ways to do it. But when I do this, I just distribute. That's just the easiest way I've kind of figured out for doing this. Now, I kind of warned you yesterday, I don't like doing the fraction rule for numbers, because you have to do it the old school way anyway. There's not like a shortcut I can teach you for that. But for the variables, you distribute the power, and you're going to take the power times the power that's sitting there. So 1/3 times 2 is 2/3. The trick that I always just tell you is just multiply the number, if it's like a whole number on a variable, just multiply it to the top of the fraction. That's the easiest way to do it. So the y will be a 7/3, and the z is a 12/3. Now I know that 12/3 simplifies, but that's how you technically do it. Make sense so far? Okay. Now we would just simplify this if you can. So if you could break down the powers where you could like actually divide them, you can. Like this one, I can't even divide the power because it's 2, the smaller numbers on the top, it's already like a reduced fraction. I can't do anything with that. So it'll stay in a radical. If the number on the top is either 3 or larger, I guess in this case, then it can simplify, like these 2 can simplify. So then you can have numbers that are outside the radical. But for the number out front, I would just do the 16 the old school way of doing this, where I would break down the 16 into just numbers that multiply to give you 16. So these are the numbers that multiply to give you 16. It's 2 times 2 times 2 times 2, right? 4 times 4, that's how I did it in my head. I just broke down 4s. So I'm gonna do the old school way, and I'm looking for triples because the bottom number is a 3. I'm just thinking about the old school way of doing it. For the variables, I'm gonna leave that one alone. Now the shortcut I told you yesterday for like any time the top number is bigger than the bottom and you can't actually divide it really well like this, you can't really divide that. Make this a mixed number. So on the 7/3, what is that? 2 1/3. If you actually like divide it out. What I mean by 7/3, like if I'm gonna actually take 7 and divide by 3, 3 can go in there twice. So 3 times 2 is 6. Like this is like old type of division, all right, it's long division. So whatever the remainder is, that's the fraction that goes behind it. So this 1 goes here, and the 3 would go on the bottom. That's how you change mixed, or I should say improper fractions to mixed numbers. So this is y and 2 1/3. Other way to do that in your head without having to do long division is how many times can you subtract 3 from the top number? I can subtract 3 twice with 1 left over. That's just how I think of it. For the z, 12 divided by 3, what is that, 4? So that one's easy. That one didn't even have a fraction. You can actually divide that. The last thing I would do here is start to take things out of parentheses and start to simplify this thing down. So for instance, I'm looking for triples, right? We do have a triple of 2s. So that triple, we're going to do the old school way, cross out 2, kick it out. Boom. So that 2 is outside the parenthesis, and this 2 is still inside, like that. For the variables, the second one I can't do anything with that because the top number is too small compared to the bottom, so I'm going to leave it at 2/3. I'll change that back to radical here in a second. I'm going to separate these. This one, because it's a mixed number, I'm going to separate into 2 separate y values, because one of them will have a radical, the other one won't. And the z to the 4th is in the back. Questions at all about what I'm doing so far? I'm hoping I didn't like completely lose you. I'm hoping that you're kind of following along with these weird shortcuts I'm telling you. The last thing that they want you to do is write it back into simplest form with radicals on it. So anything that has a fraction for the power is going to go back into a radical form. So it looks like on this particular problem, the 2, the y, and that z, since there's no fractions on it, these select items, those 3 items, they're going to be out front of the radical. So I have a 2, a y squared, and a z to the 4th. Now the radical I'm going to have left over is a 1/3. It's a cube root. How I know that is all the bottom numbers are 3s. So I'm going to have cube roots. On the inside will be all the items that still have the fractions on them. And you just have to make sure that their powers are correct. So what do you mean by powers? Because we know they're 3rd roots. This is going to be 2 to the 1st power, so that's just 2. This is going to be x to the 2nd power, which is inside the radical. So that's x squared. And the last one is y to the 1st power. There's your answer. Now, I know a lot of people when they first look at that, it doesn't look like a shortcut. It definitely is if you've learned if you've actually like practiced this enough. Doing it this way is actually way simpler than trying to write out all those variables and then try to circle pairs or triples and you're going to kick them out because, you know, in this case, if I were to write this out, you know, using a radical and, you know, I think the method of DSA did that factor problem where I broke down 16, broke down x's, y's, and z's, and I was looking for triples. There's a lot of items written down. I don't want to have to go all the way across my paper and write out 12 z's and then circle 3 of them. You know, the 3 pairs, or 4 pairs, I should say. I don't want to do that. All right. Is there any concerns with that problem? Does anyone need to see another one just to make sure you're comfortable with it? Good? Okay, good. I'll take silence as yes, unless you just want to ask a question later. Okay, let's move on. That was really good. I have to spend a little more time on that than I wanted to, but let's move on. Let's do a fraction problem. Okay, and I'm gonna try to do it for maybe like a 4th root. I don't know if we did any of these yesterday with numbers and variables in it. So let's do a 4th root. So let's go with like Let's go with 4x squared, and we're going to put this over top of, let's go with 25y to the third z. So I'm hitting pretty much everything at once. They want you to simplify this radical, and I think the directions say rationalize the fraction. That means just get rid of the radical off the denominator. So whatever the bottom is, it does have a radical. Since this is a quotient rule, you can separate the radicals. We'll have to get rid of it. It's a fourth root, keep that in mind, it's not a square root, so you gotta keep writing the 4 in the little index number spot. Can I simplify anything on the inside before I start? Is there anything like, can I divide by 2's or x's or anything like that? If you can't, then we're just gonna start by separating them and then going right into the process of trying to simplify it. Okay, so first, we separate into their own radical. So fourth root 4x squared over top of fourth root 25y to the third z. So we separate it. Now, I don't know how you want to do this. I don't know if you want to, write everything out like side by side. I think that's probably easiest if you do that. What I mean is that you can leave the top alone. The top really doesn't really matter right now, because we know we can't break that up to take radicals of it. But the bottom, I'd say the easiest way to do this on the bottom is to break it down like what we've been doing all day yesterday and the day before, where you just separate like 25 into the numbers that multiply give you 25. And you separate the variables into their own factor, basically expanded factor form, using that definition of an exponent. Now, why I would choose to do that is because now by seeing the bottom, I know instantly what I need to multiply by to get the correct number of pairs or quads. Because I'm looking for groups of 4s, right? That's the index number is 4s. I need to make sure to get rid of the radical off the bottom. I need to get all of those items that are in that radical to have 4 of them. Because I have to circle quads, 4s. So what do I need to multiply on the bottom to guarantee that there's 4 of each of these items? How many 5s will I need? I'll need 2 more. How many y's will I need? 1. And how many z's? 3 more, right? To make 4 of everything. So that's what we're going to do. We're going to add these on. We're going to multiply the top and bottom by everything that I'm going to add to the bottom. So I'm going to add 2 more 5s, 1 more y, and 3 more z's to guarantee that there's 4 on the bottom. And then same on the top, 5, 5, y, z, z, z. Because I need to have 4 of everything. So now, when you do this, when I multiply, usually I just like kind of multiply the top together. If you've already separated the top to be like 2 and 2, x and x, that's fine. But the bottom will guarantee that I'm going to have 4. So if I just make this one large radical, I'm just going to do this and multiply that to the bottom. Now I have, I have 4 5s. So that means since it's a 4th root, one of them is going to the outside because you always cross mount, kick one out. The y's, now I have 4 of those, so I'm going to cross mount, kick one out. And then there's 4 z's, so I'm going to cross mount, kick them out. So there's your bottom. Those, the 5, the y, and the z were kicked out of the house. There's nothing left in the house. On the top, though, I have to look to see if I can do anything up there. Well, on the top, if I actually broke this down, there's really no, quads of anything. There's 2 2's, 2 x's, a y, a couple z's, and a couple 5's. There's not 4 of everything. So it looks like I'll just have to leave that up there. So 4 times 25 is 100, so that's still under the radical. It looks like I have 2 x's, a y, and 3 z's. There you go, there's your answer. That's a simplified form for a fraction. The reason why I'm telling you to do it this way, this strategy, is it'll allow you to never have extra stuff and extra steps. It'll give you the bare minimum things you need to multiply by, like a tack on, And it should guarantee that you're not gonna have to simplify things on the outside of the fraction at the very end. Because sometimes, like, if you're just to multiply by random things to try to get this thing to have a quad, you might accidentally multiply by too many extra things. And so when you simplify them and they kick to the outside, the top might actually simplify as well. And then you have to look on the outsides to see if anything more were to simplify. Because maybe there's like a 15 up here that's on the outside. So the 15 and the 5 can simplify. But by doing it by this strategy that I'm showing you, it should guarantee you wouldn't have to. As long as before you started, you check to see if I could cross out anything first. If there's any negative powers in here, move them around before you start. You know, make them positive, move them to the opposite side of the fraction bar. Then just do the steps I'm showing you here. Questions at all about this problem? If you could follow that, you're more than fine with the ones I assigned. Like that's overkill. I just want you to be comfortable with it. All right, last one, sum and difference. This could be your last problem. This depends if you guys feel comfortable with it. You've probably already seen this stuff before. 8x plus, let's go with 4, 2x. Let's say that this is our problem that we have. It could be anything. It could be a cube root, it could be a fourth root, it could be any type of root. I just pick square roots. I cannot add these as they sit right now. The reason being is it's not like multiplying. Multiplying, you can multiply any type of radical together. You can divide any type of radical you want. But when you have two that are being added or subtracted, they have to have the exact same radical on them. It's because what I think of is like, you have a number up front, you have a 1 sitting here. They don't have the same radical. So they don't even have the same variable. It's like doing a 2x and a 3y. That's kind of what it compares to me. That I can't actually add them yet. But you have the luxury of taking this problem and simplifying it. Like I can simplify this. There is a perfect square there. Over here, I can't simplify that. So this is pretty much left alone because the 2x, I can't break it up any further and kick things out. The 4 is just on the outside. But the 8, how can I break up 8 though? Bunch of 2's, right? 2's, 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 and an x. And so this is a square, so it's got a little index number 2. I can circle a pair, kick one out. So cross one out, kick one out. So it looks like there's going to be a 2 joining the 1 on the outside. It looks like I'll have the 2x left over because I didn't even circle those. Over here I had the 4 and the 2x. And 2 times 1 is 2. Boom. Now I can add these together. Because now they have the exact same radical, they have the same variables, they have the same powers, everything. So if everything matches, now when you add these together, you just add the leading number out front. So you have 4 root 2x's, you have 2 root 2x's, now you have a total of 6 root 2x's. That's how you do that problem. You can actually add them. Again, that works for adding and subtracting. Just make sure, like if they don't simplify and they don't like match, you can't add them. That's your answer. Like it doesn't add together unless the radicals exactly match. It can work for variables, even if you're kicking variables to the outside. You just have to make sure that, let's say there was a z out here, and you had a z squared here, and you kicked the z out, and you already had a z on the outside here. That's fine, as long as they have the same variables. That's what you have. You have 6z root 2x's. Questions with how to add or subtract? Okay, here's your homework today. You'll have the rest of the time today to kind of work on it. Plus, we'll try to give you some time tomorrow. Tomorrow's kind of a light intro day to notes on the next section. So this stuff is due Monday. Just like all your other assignments, it kind of bounced around. I kind of pick routes here and there to get kind of a practice on each type. Okay. So homework, and I'll put it over there here in a minute. Homework due Monday. All right, due Monday, here it is. It's page 43. your numbers, 14, 18, 21, 28, 29, 32, 33, 39, 50, 51, 68, 73, 7, 8. Looks big, menacing. It's not. It's just I'm bouncing around so much, trying to pick up just a couple problems here and there. A couple problems with square roots, a couple problems with cube roots, a couple fractions with squares, a couple fractions with cube roots, some with variables. And then I think the last three are like add these couple radicals together. There's a couple in the middle, I think it's like 80s, the 80 range, like 73 through 87. I think those are the ones with the fractions for the powers. So they're having you simplify the fractions. There might be one problem that there's probably one problem that holds on that I think is actually kind of challenging, maybe. But if you pay attention, you should be able to kind of work your way through it. The rest of them are really good. But there you go, there's your homework. Yeah, the rest of the time to work.